All right, so today we're going to be talking about domains of functions. So let's go ahead and start with square roots, because there are several things that will limit the domain. One of them is square roots. So anytime you have a square root as a function, what you want to do is that remember that whatever is underneath the square root, all of this area must always be greater than 0. So if you have the square root of x plus 3, the domain of this function is x plus 3 must be greater than or equal to 0. And this is always going to be the case. Whatever is underneath the square root, set it greater than or equal to 0, and this will be your domain of the function. So in this case, we get that x must be greater than or equal to -3. And then to go ahead and write this in interval notation. If you're having problems with interval notation, I think the best way to think about this is still the number line. Because interval notation is just a numerical representation of the number line. So what we have for this is here I'm going from -3. -3 is included, so that's a solid dot, or in interval notation it would be a bracket. It's going same way as the arrow, this direction, forever. So that way my interval notation says I'm going from -3 to positive infinity. Now, to find the range of this, go ahead and start thinking about what would happen if you took that -3 and plugged that into that function. Well, that square root function, when you plug that in, that would give you the square root of -3 plus 3, which is the square root of 0. So your range here starts at 0. And in this case, it's going to go towards positive infinity. How do I know that? Well, if I go ahead and plug in another value here, you're going to see that's going to be the square root of 1, which is 1. And then also keep in mind that that square root function always has this shape. So the range for this one would be going from 0 to infinity. And 0 is included in the square root. The next major place that we have is fractions. So if you had a fraction that looked like this, x times x plus 3 all over x plus 3 times x minus 2. What limits the domain of fractions is the fact that 1 over n is your fraction, but remember, n can never equal 0. So in this case, you have to be careful. Even though I can go ahead and cross out that x minus 3, it does not matter. Your original portion has x plus 3 times x minus 2 in the denominator, and nothing in the denominator can ever equal 0. Now, this x plus 3 is a removable discontinuity, but it is still has to be excluded from the domain. So with this, I can say x cannot equal a -3, and x cannot equal a positive 2. Now, how do you write that in interval notation? Again, I always like to go back to the number line. That means everywhere on my number line, except for 2 and except for -3 are okay. So -3 gets excluded and 2 gets excluded, but I have the entire rest of that number line to deal with. Now, this becomes three parts. I have this first part, which goes from negative infinity up to negative 3. It does not include 3. I have to make a union symbol to join it with negative 3 to 2. And again, I join that one more time with 2 to infinity. Now, there's one more place that we have to worry about the domain of functions with, and that is if we have complex fractions. So with complex fractions, we have fractions that look like this: 5 over x, and then 1 plus 2 over x plus 3. So there's two things that you have to worry about with this. One, what is the domain? And you have to limit the domain of each fraction. So inside this, I have 5 over x, and in this fraction, x cannot equal 0. And then also for this fraction, you have x plus 3 cannot equal 0, which means x cannot equal negative 3. And then we also have to make sure that the domain of the entire denominator, which is not just this fraction that was in the denominator, but that this entire fraction, the whole thing on the outside, all of this cannot equal 0. Now, when we're doing this, that's saying 1 plus 2 over x plus 3, that whole entire fraction cannot equal 0. So to go ahead and solve this, we'll subtract 1 from both sides, and then we'll be left with 2 over x plus 3 is equal to negative 1. Multiply both sides by x plus 3. And then you would be left with 2 is equal to negative x minus 3. Or that 5 is equal to negative x. Whoops. Again, that's cannot equal. And x cannot equal then negative 5. So that was one of our solutions. Let's go ahead and put up there what else was in there we couldn't have from the beginning. From the beginning, we could also had in the fact that x could not equal negative 3 and x could not equal 0. So to put all of that in interval notation, always go from negative infinity to the next smallest number, which in this case is negative 5. I union that and go from negative 5 to negative 3. And then lastly, oops, I take that back, not lastly. Then I'm going to go from negative 3 to 0. And finally from 0 to positive infinity.